this, or what I tell you might be really helpful for when you take the science classes. All right, but first we have a scatter plot. All right, that's a graph in which the values of two variables are plotted along two axes. The points do not connect. The pattern of the resulting points reveals any correlation present. What does correlation mean? Similarities, like between the two variables. So any similarities between the two variables. What else? Or what was that? What's another word for correlation? Right? No. I've gotten like a bunch of blank stares today too. So I don't know if we just don't learn this ninth grade anymore like they have in the past, but yeah. Anyway, a correlation, that's actually what this thing is. It's kind of like a relationship between the variables, or a pattern between the variables. So it's the measure of the linear relationship between two quantitative variables. What does quantitative mean? Numbers, numerical values. So like age and shoe size. Is there a correlation between the two? Is there a relationship between your age and your shoe size? All right. Other things like weight and height. Is there a relationship between your weight and your height? Maybe, who knows? We'll have to plot it and see. But a correlation is a measure of that. So there's positive correlation, negative correlation, and no correlation. So if it's positively correlated, what will it look like? It will go up. And this is a scatter plot, so you have a bunch of dots. They don't need to be perfectly in a straight line. You just need to be able to tell that it's going up for the most part. So positive correlation, as the x's increase, so do the y's. What about a negative correlation? Going down. Do they have to be in a perfectly straight line? Can they be? Yeah, they might. Usually in the real world, it's hard to get data in a perfectly straight line, but of course it just depends on whatever it is that you're doing. And then no correlation, what would that look like? Okay, no specific pattern. You can't really tell if it's going up or down. So that could be an example of no correlation. Another example of no correlation could be if it's like a straight horizontal line. All right, so there you go. No correlation, no pattern. You can't tell if it's going up or down. So questions on that? All right, so then scrolling down, little bit of more vocab. One way to quantify, so to give a number to the correlation of a data set is with the correlation coefficient. Which is denoted by R. The correlation coefficient varies from -1 to +1, with the sign of the R corresponding to the type of correlation, positive or negative. So if you're asked on a test to estimate the correlation coefficient, the R value, you should not be telling me a number outside of -1 to +1. If you do, you're automatically wrong. So like 2, 3, -4, -1.5. Not possible because it has to be between -1 to +1. All right. Strongly correlated data points look more like points that lie in a straight line and have R values closer to 1 or -1, depending on how if it's positive or negative. Weakly correlated data will have values closer to 0. All right, so then scrolling down. Based on the information I just gave you about correlation coefficient, positive or negative correlation, predict the R value of these 4 graphs that you have. You have some options over here, whether it's closer to -1, -0.5, 0.5, or 1. So describe the correlation, indicate what R is closest to. Do that within your groups, make sure you guys all come to an agreement. So that way when I call on someone, it's not like painfully awkward. It's okay if you're wrong, but like calling on you and it's just like silence for like a whole 2 minutes is not fun. So let's do that. Right. River, what did you say for the first one, top one? Okay, so definitely a negative correlation. Did you estimate the R value? Okay, so let me go to a different person. Michael L. Would you say that this is strong correlation or weak correlation? Strong, what tells you that? I agree with you. So the line goes down the middle of all the dots. Would you say that these dots are pretty close to the line?
Yeah.
So they're almost in a straight line, not quite. It's really actually hard to get data in a perfectly straight line. So I would agree, strong negative correlation. Fabian, what R value do you think it would be close to? Out of these 5 options? 1.
Yeah.
All right, class, agree, disagree? Okay, what should be changed about it?
-1.
Okay, good. So whether it goes up or down will tell you if it's positive or negative. Whether it's closer to 1 or -1 depends on if it's strong. If it's strong, it'll be closer to 1 or negative. Okay. All right, then Isabella, what did you say for this one? Top right. Tell me something about it. You do it. Sorry, positive. How do you know? All right, thank you, Caleb. Yes. And then Caleb, would you say this is strong or weak? We'll take a guess. If this one's strong, do you think this one's strong? Okay, I agree. How you tell if it's strong or weak is how close it is to being in a straight line. Not perfect, so it's not 1 exactly or -1 exactly for the first 2, but it would be close to it.
Miss Medina. Okay, sorry, I thought I sent it. No problem.
All right, but yes, that one is closer to the positive one. I gave that one away. You'll know that it's closer to 0 if you can not tell much about it being going up or going down. So if it's no correlation at all, that would be where R equals 0. If it's, you can kind of tell it's going up, then it's probably closer to 0. It might not be exactly 0, but that's how you do it. All right, so then scrolling down, table 6, can you tell me what this R value is close to out of those 5 options? All right, class, agree, disagree? Okay, yes, definitely negative, strong or weak? Weak. So you can still tell it's going down, but it's not as close to being a straight line as the top. So weak, negative correlation. And then table 7, what about this last one? R value is closer to what? Positive 0.5. So weak, positive, correlation. All right, so if you are asked to estimate the R value, you will, I'm telling you now, you will be asked that. Use that in your consideration, whether it's going up or down would be positive or negative. Whether it's close to being in a straight line, it's closer to 1, or -1. Adelie? Yes. All right, so a little bit more vocab. So that's scatter plots. First blank we have here is a line of best fit. Also known as a trend line. I feel like that's mostly what we called it in college. All right, a line of best fit or a trend line, table 2, stop counting, is a line through a set of 2 variable data that illustrates the correlation. So those scatter plots you had on the first page toward the bottom all had the line of best fit drawn through them for you already. Usually you have to draw it yourself. So when there's a strong correlation between the 2 variables, you can use the line of fit as a basis to construct a linear model. So you can use it to make other predictions, essentially. When estimating the line of fit, sorry, it's hard to see with that fire alarm. But you're going to draw the line that the data points appear to be clustered around. It is not important that any of the data points actually touch the line. Instead, the line should be drawn as straight as possible and go through the middle of the scattered points. If it happens to touch a data point, great. Does it have to? It does not have to. As you noticed on the first page, none of them actually touch the line. Like maybe like a part of it does, but not all of them are on the line. Right? So this has to go through the middle of the data. Questions on that? All right, so that should be easy points on the test. Drawing the trend line through your data and making sure it's in the middle of your points as straight as possible. All right, then you're usually asked to estimate that line of fit. So don't tell me, table 9, what equation do straight lines always have?
Slope.
Slope. Table 9.
Oh.
Slope.
Intercept.
Intercepts. Form. Yes, slope-intercept form is all of our straight lines, right? Y equals mx plus b. So once you draw your straight line, look at where that line is. And first thing you're going to do is identify 2 points that appear to be on the line. So will it always be a data point? No. Want it to be the line. So sometimes none of the data points touch the line, like this one. None of them are directly on the line. So table 1, can you tell me a point that happens to be on the line that you can see clearly? 35, 65, let me go back and verify. Let me check again. 35, 65 would be right here. So not exactly on the line. What did you say for that Y value? The X is 35. Do you need to reverse your coordinate? Okay, so then what is it? All right, let's see. 65, 35. That works. So remember, it always goes X and then Y, so 65, 35 is on our line. Someone else volunteer. What's another coordinate that's on the line? That you can see clearly. I'm gonna give someone else a chance. If no one else volunteers, I'll call. So another point that you can see on the line, try to avoid having to estimate. Like earlier, someone said 30 and like 72, 73. Avoid having to estimate. Try to see if you can find it where it goes nicely through like the grid line. Tyson?
60-40.
60-40. So yeah, I agree. That one's directly on the line. So once you identify those 2 points that appear to be on the line, you're gonna calculate the slope. What formula do you use to calculate the slope? That slope intercept form. To just calculate the slope, the M you use, you could use rise over run if it's nice numbers for that. What else? There's like at least 3 formulas, right? Close. If it's rise over run, it should be y2 minus y1 over x2 minus x1. And then there's one more, usually people forget about this one. But change in y divided by change in x, all of those are for slope. The one that's probably most helpful when it's 2 coordinates is the middle one. All right, rise over run really only is helpful if the numbers are nice on your graph, and they're not always. So I would just say go with y2 minus y1 over x2 minus x1. So to use that one, label one of your coordinates as x1, y1, and the other as x2, y2, and then plug it in. Keep in mind, like the person next to you could have chosen different coordinates and they'll get really similar answers. Because we're estimating the trend line. So depending on what coordinates you pick, we might have slightly different answers, but they should all be around the same numbers. All right, but if I chose these and I labeled it that way, it's 40 minus 35 over 60 minus 65. What's 40 minus 35? 5. What's, or yeah, 40 minus 35, okay? And then 60 minus 65. And then divide those, what do I get? -1. So my slope is close to -1. Now we're making the equation of the line. So y equals mx plus b, we really only have the m right now. Tomorrow I will show you how to get the b. So I don't want to start it and then not be able to finish it. So we'll pick up here tomorrow. Tomorrow I'll also show you how you can still get the same answer having used other points that are on the line. Burn this.